Okay, so here we have question number 1 from the Mechanics 1 paper from January 2019, International A-Level EDEXCEL. Question about momentum, it seems. Two particles A and B have masses 2m and 3m respectively. Respectively means in that same order. A is 2m and B is 3m. It's got nothing to do with respect. They are moving towards each other in opposite directions along the same straight line on a smooth horizontal plane when they collide directly. Immediately before they collide, the speed of A is 3u and the speed of B is u. As a result of the collision, the speed of A is halved and the direction of motion of each particle is reversed. Find the speed of B immediately after the collision and find the magnitude of the impulse exerted on A by B in the collision. Okay, it's a classic type of momentum question, and you have to take very much care when you're dealing with mechanics and directions. Okay, so you have these particles that are heading towards each other. Okay, they're heading towards each other on a straight road. You're supposed to use black pen, by the way, when you do these questions. I'm using blue. I'm kind of cheating because just to make it look a bit colorful. But you're supposed to use black pens because your exam papers are scanned in, and it says it very clearly at the front of the paper. Okay, it says use black ink or ballpoint pens. Very clear. Except for diagrams, you can use pencils if you wish. Okay, so now you have. Now it doesn't matter which one of them I call A and B, okay? And that will come into make you understand something a bit later. So I can call this A, I can call this A as I wish. So I'm going to call, most people would call this A and call this B. Okay, so I know that the mass of A is 2m and the mass of B is 3m. Okay, I know that they're moving towards each other, so they're going in this direction. Okay, they're moving towards each other. So if A was over here and B was over here, then of course you'd still have arrows going towards each other. It says immediately before the collision, the speed of A is 3u and the speed of B is u. So this is like considering what's happening before the collision. Okay, after the collision, I'll write the after part down here. What's happened is the speed of A is halved, okay, and the direction of motion of each particle is reversed. So I know that this speed is, first of all, it's going in the opposite direction to where it was going before, so it's going to be 3u over 2, it's halved, okay, 3u over 2, and for B it's going to go in the opposite direction because it says the direction of each particle is reversed, but we don't know what its final velocity, I'll call it VB, or the final velocity of B. Okay, find the speed of B immediately after the collision. So that's what we have to find. So what we need to know about momentum is conserved. That the total momentum before the collision and the total momentum after the collision is going to be the same. And the momentum is given by the mass times the velocity of each of the particles. So the momentum before of both particles altogether is equal to the momentum afterwards. Is equal to the momentum after the collision. Okay, so let's look at the momentum before. Now what I'm going to do is I'm going to choose a direction to be positive, right? And normally you choose right to be positive. It doesn't really make much of a difference in the end, but you have to be consistent. So I'm going to choose right as positive, okay, and you have to be really careful about directions in these questions, as I said. Otherwise a lot of people lose marks because they mess up the directions. So if I'm taking right as positive, before the collision, if you look at the total momentum. The momentum of A, remember momentum is mass times velocity, right? So the momentum of A is 2m times 3u, and the momentum of B is 3m, but the u is going in this direction, which is opposite to what we have called positive, so it's minus u. 3m times minus u. And after the collision, the momentum of A is 2m times, and now this time this is going this negative direction because it's reverse directions. So it's times minus 3u over 2 plus, and you got 3m times VB plus 3m times the velocity of B. Okay, so now what we need to do is just simplify and solve this equation that we formed. So we got 2m times 3u, which is 6mu. And we got 3m times minus u, which is minus 3mu. And you got 2m times minus 3u over 2. The 2's cancel, left with minus 3mu. And you got plus 3m times the velocity of b. Okay, so we can now simplify this. This will be 3mu plus 3mu, which will be 6mu. Okay, because these two will give you 3mu. You have to add 3mu to both sides, equals 3m vb. So we can say the velocity of b is going to be 6mu divided by 3mu, which will give you 2u. Okay, so it's asking us to give the speed of b immediately after the collision. We know that it's going in the opposite direction, so we don't have to write that. But sometimes the questions would say, find the speed and direction of b immediately after the collision. Maybe they wouldn't tell us that both of them have been reversed. Maybe it says just a has been reversed, and find the velocity of b, and find the speed of b and its direction after the collision. Or it might say find the velocity of b, in which case you'd have to give the speed and the direction. Now when they ask for direction, supposing this question did ask us for a direction, okay, and they didn't tell us the direction, we're not going to say going to the right, because you could have taken to the left as positive. You could have put your a here, you could have put your b there. In that case it would be it would be wrong to say to the right. So you don't mention a direction in terms of left and right. You mention the direction in relation to how it was moving before. So you can say here that the direction has been reversed, because before it was going left, now it's going right. So you would say that the speed is 2u and the direction has been reversed. You don't mention right or left, because it depends on how people draw the diagrams in the first place. Okay, so that's an important point, but in this question you don't need it because they already told us the direction. They just wanted us to find the speed. Now part 2, it says find the magnitude of the impulse exerted on A by B on the collision, in the collision, sorry. Now, so that means we need to find the change of momentum of A. The magnitude of the impulse exerted on A by B in the collision will basically be the change of momentum of A. The impulse, okay, is equal to the change in momentum. Impulse is equal to the change in momentum, which is the final velocity times momentum minus initial velocity times the momentum, which you can write as m times v minus u. So we can consider A or B, because the impulse exerted on A by B is equal and opposite to the impulse exerted on B by A. But it's always best to choose the one that you know the values of the speed before and after the collision without having calculated. So if I used B here, I had to calculate the velocity of B, and maybe I made a mistake, right? So you won't get error carried forward for that. But here, if you use A, you know what the speed is before the collision, and you know what the speed after it said it had been halved. So you know what the speed before and after the collision is. So you can use A. So if we consider A, and in fact that's what we really need to do anyway, because it says exerted on A by B. So what we're going to do, here is we're going to find the speed before the collision, which is u, and that is 3u, and the speed after the collision, which is negative 3 over 2u. Okay, so we're considering A, so the mass of A is 2m, so we're going to have 2m times its velocity before, 3u, minus 2m times its velocity after, which is minus 3 over 2u. And that's it, the impulse. So the impulse is going to be 6mu plus 3mu, which is 9mu. That's the impulse. They only want the magnitude, not the direction. Okay, not the direction. So if they ask for the direction, the magnitude exerted on A by B, it would be the impulse is 9mu in the direction opposite to which A was traveling before the collision, something like that. Okay, so there we have the magnitude of the impulse before the collision, and there we have the velocity of B after the collision, part A and part B there completed. Okay, maybe more complete if you write the velocity of B after the collision is 2u, the magnitude of the impulse exerted on A by B is 9 mu, and that would be that. Okay, thank you for watching.